Alright, this is a video for Lab3 and this is Shane. Um, for this lab we will cover the Datum Planes and Datum coordinate system as well as some design features. And at the end of this video, in part 2 and part 3, we will introduce you two project parts. One is the top blade and the other one is the spring. Okay, so let's start on the lab portion. Alright, so Datum Planes, as you can see here, we have for every new file we have a new Datum coordinate system, which has three Datum plane already, the XY, right, YZ and ZX. So what if we want to create a new Datum planes for reference or for building some new sketch? So today we're going to introduce how to build a Datum planes as well as the Datum coordinate system. Okay. So we have two different kind of Datum planes. If we come here, use this to create a new Datum plane, and in the setting tab you can see there's the checkbox. So if this one is checked, that means this is a relative Datum plane. So which means this Datum plane will use whatever you pick here as the reference. And if you uncheck this box, that Datum plane will be a fixed Datum plane, and so this Datum plane will have no reference, and the object you pick here will not affect the Datum plane you are creating. Alright, so most of the time we will just use associative to create a relative Datum planes. Okay, just in case you want some independent Datum planes, you can uncheck this box. Alright, so we have a couple different methods to create Datum planes. Inferred is basically like automatic, or it's basically the same as at distance. So first you're gonna pick one object. So we can pick a Datum plane, or we can pick a face on a solid. So let's pick XY plane, and then you can create. By default, it's gonna be at 0 inch away from the object you just picked. So we can change this distance by pulling this handle, okay? Or you can type in the number for more accurate distance. So basically this is exactly the same as at distance, okay? And if you click apply, we will have another Datum plane here. So now you can start a sketch on top of this Datum. Alright, now the next method is at angle. So at angle is a little bit tricky, as you can see in the slides. You have to pick two objects. One is the planar object, the other one is the linear one used as the axis. So let's insert a box first. Let's insert design feature block. Okay, and something like this. Okay, so what if I'm drawing something? I want to draw a sketch which is at distance, at one angle, not vertical or horizontal plane, like maybe 45 degrees away from this vertical plane. So what we can do is we can use the at angle method in this dialog box. First, we can pick the planar object. Okay, we can pick this one, which is at 0 degrees. Okay, then we can pick the axis. So if we pick the vertical one, the datum we are creating is gonna be like a door. Like a door open from this plane using that axis. If you pick the top, it will feels like it's hard to say, like this. Okay, so that's how you build a at angle datum plane. And as you can see, the edge we picked is your axis, and you can type in an angle to make sure this one is what you want. Okay, like 30 degrees. Alright, now you can build a sketch on top of that. Now that's the at distance, which is pretty much the same as inferred. And then we have another one is pretty powerful on curve datum. So if we have something like this, okay, a spline, you can build different datums along the path. So first we can try to build a sketch where we're going to build a spline. Okay, the spline command is here. You don't really need that, but just let you know. So we have a nice smooth curve here, and I'm gonna finish sketch. As you can see, this curve is on the 30-degree datum. And what if we want to build something that's normal to this curve? We can use the Datum Plane dialog box, and you have the option to build a on curve datum. Then you can pick first you can pick the curve. Alright, as you can see, we have the option to choose from the arc length or the arc percentage length. So percentage is pretty neat. You can define 0 is the start point, and then 100% is the end point. So we can put like 75 percentage. So, and then if you note here, you have different options. You can use normal to the path, which is by default. Okay, as you can see, it's always normal to the path. And you do a tangent and binormal, which is the other tangent. Okay, not really. Binormal is like coplanar with this spline. Okay, so most time we just use normal to the path, and you can try different options. All right. So that's the way you can make a datum that's normal to a path. Excuse me. So now we can create the datum plane. We can also create a datum coordinate system, which is the same as this. So maybe at first some of you will accidentally delete this one, and how do you get this back? You can come here, expand the menu. You have datum CSYS coordinate system. You can use this command, okay, to create another datum coordinate system, which is exactly the same as that one. And I'm going to create this one away from the first one. Okay, and you have also different options. Dynamic is basically you can drag and you can type in the coordinate of the orange point, and you can move along 3 directions, or you can rotate along 3 directions. Okay, so that is pretty easy for some regular position. If you want to do like um, if you want to build a coordinate system that's based on what you have, like orange XY point, so you have another option. Let's say we want a coordinate system here. First, we're gonna specify the orange point. Okay, and you can say, since my y is this direction, I can have a vertical y here. So I'm gonna specify the y to be the vertical, and then you can specify your x. Okay, so that will give you this kind of a coordinate system, which is kind of flipped uh, with respect to the original one. So if we hide the block and all the other things, you can see this one looks exactly the same as this, just at different position. Okay, so this Dayton coordinate system is pretty useful when you have something like this in the slide. You want to build a lot features on the cylinder, or normal or perpendicular to the cylinder, and also you want to build some features on this block. And as you can see, all the feature on the cylinder will be at angle to the original system. So it will be a pain to build a lot Datum planes at angle to your original system. So why not just build another coordinate system here? That'll be a lot easier. Okay, so it depends on your application, your model. Alright, so here's some different methods you can use. And next we're going to introduce some design features. Besides the extrude revolve, we also have some advanced tools. First is the mirror feature. So let's say if I have a very complicated shape here, maybe a piece of machinery. So I don't want to do the same work for the other side. Maybe this one is symmetric. Okay, so what we can do is we can use mirror feature to copy this side to the other side, and this command is deep down here, insert associative copy. Then let's go to mirror feature. Okay, once you click this, you can pick your object or pick your feature. Okay, how to pick a feature? You can click the feature itself. Here is the block. You can also pick the feature in the part navigator. Sometimes it's hard to pick something like a edge blend, a hole, or you want to pick multiple features. Like if I want to pick all of this, okay, and mirror them to the other side. So let's next define the mirror plane. We can use ZY plane, okay, and as you can see, there's a smart dot indicating all the features will be at this position. Okay, and we can click apply. Now you can see we have the box, and we also have all the features on the other side, and we can show them. Okay, so that's pretty nice, and that's a quick way to create a symmetric geometry and for complicated shape. And it's not only it can also mirror the features like a hole, a edge blend, not only a box. Okay. So next um, is the swept. Swept is pretty useful for a complicated shape like this part we did in the summer. And you have different cross sections, but um, they let's say they scan along a certain path. So that this path will be your guideline, and all the cross sections will be the section. Okay. Um, Maybe I can open that file for you. Okay. Here's what we did using swept. So as you can see, the shape is pretty complicated, and it's hard to use extrude or revolve. Okay, and this thing has um, a lot different cross sections, and you can use different cross sections to define very complicated shape. And then you have your scan curve or swept uh, direction. That's your guide. Okay, so let's go back to the model. Maybe we can build another swept for you. So we have one Dayton here. We can build some snake-like shape based on this spline. So let's first get some different cross sections. Now we need a couple different datum planes, so we can define the shape of each uh, cross section. Okay. So I want this to be the end 0%, and we can hide this as well as coordinate system. So here we can define 3 cross sections. Now let's build a sketch on the start point, and then okay, that will have very interesting orange. So let's start with maybe something weird. Just for demonstrating. Okay, and as well, as usual, the sketch quality should be good. You don't want sticking out curves that will give you invalid sections. Okay, now we finish this sketch. Okay, that will be our start point. Then we can go to the middle, build another sketch, and now here we can have maybe relatively easy shape like this. Okay, and at the end probably something weirder. Okay. 3-point arc, start point, end point, then the middle point. Finish. Alright, let's see what happens. Okay, now the swept command is here on the surface toolbar. If you cannot find this, you can use command finder. Okay, So here we have a couple of different tabs. We have the section tab, which is for your cross sections. Then the guides. Guides will be your guidelines. You can have three maximum for the guidelines. Okay, you have some other options. We can talk about that later. So for here, I think by default it will look like this, and you want to expand this. Each set or each entry here will be one cross section. So first, let's pick the curve and pay attention to this curve rule, which is kind of like a filter. You want to pick connected curves because obviously your cross section is not tangent. Okay, or you can use single curve, pick them one by one. So let's pick the connected curve as the first cross section. So here let's proceed to the next section. You want to add a new set. Okay, so for each set there will be a cross section. You don't want to mix two cross sections in one set. So here we're gonna pick the second cross section. Then we're gonna add another one as the third cross section. And here you can see there are some directions. Okay, so actually each section is a closed loop, and each closed loop you have your origin curve, which is the start of that closed loop, and you have the direction of your closed loop. So for instance, I can change the direction of the curve. That's counterclockwise. We can make this clockwise. So for a good quality swept, you want all the cross section to be at the same direction. So this one is clockwise, and when you scan through the line, that's also clockwise. Then let's go to next. That's still clockwise. So you have to pay attention to this. And lastly, you have to define the orange curve. Okay, so here it's correct because this one is the top. Okay, that curve is on the top too, and the last cross section we have the start curve on the top. Alright, now we can select the guide curve. So we only have one here. That will give us the geometry right away. Okay, well, as you can see, we do have some nice shape, but some will say this top line should be aligned with this top line. Why this corner goes here, right? So that's the alignment option. We can use parameter or we can use by point. So by point will give you some points for each section. So for this first section, you have those point, and this point will be aligned with this point on the cross section 2. Okay, and that's the section 1.8, section 2.8. Okay, if you want, you can move those points to make sure they align properly. So that's a tedious work, and for this course we don't really need that. That's more like a visualization work. So you can play with this option, and you will learn something about this. Then the second option is here, the linear or cubic. Okay. So linear will give us pretty sharp angles. The cubic will be smoother, and I'm sure you all know that's from the linear equation or cubic equation. So cubic equation, of course, will give you more smooth looking on the curve or on the geometry. Alright, so that's all for the swept, and I recommend you to play with this. That's a pretty powerful tool. You will be able to make a lot complicated shape like this one. Okay, and so that's all for the lecture part. Then in the second and in the third video, I will talk about how to create this spring for the project. And of course, this one is idealized from the real thing. Then the details, the major steps are here. Okay, you want to take as many screenshots as possible, and you want to think of this as writing your actual report, so you don't have to come back and take another screenshot just in case you miss something. Okay, so along the way you can pretty much finish the report during for the homework. Okay, then you just put everything together, and then you have the midterm report. So for Lab 3, the homework gonna be the spring only. Okay, this top blade will be for next week, but I recommend you to finish this if you can, or at least finish half of this top blade. Actually, that's not very hard, and since we still have another blade and we have the handle coming, so those gonna be two major parts will be more complicated, so you will spend more time on those parts. So when you have time, I really wish you can finish these two parts in this week. But um, after all, for the homework, you only need to submit the spring. Okay. All right. So see you in part 2 video. Thank you very much.